Hello, and thank you so much for joining us today in the November Demystifying Post-Productions webinar. And the theme for the November webinar will be around color management. And we are very lucky that today we are joined by our friend, Nosman, the master trainer at Maxon, and he will guide us through about the basic principle of color management. So he kind of demystify the concept of color management in a layman terms, something that we can understand like really easy. So that's the agenda for today, and next week we will talk about color management inside Cinema 4D with Redshift. And we'll be joined by Lionel Vicidomini, the master trainer at Maxon. And then also the next sessions after that, he will kind of break down the color managements inside After Effects, if I'm not mistaken, right, Nosman? And then
I have no idea.
yeah, I think he will do some compositions in After Effects using ACES color management. And then after that, we'll take things into the grading suite, and then we'll see how we can set up some color management, in this case ACES, inside DaVinci Resolve, and then also see how we can guarantee the consistency in the QC area. Because at that time, Tony Bari will be joining us, and then also Diego Yama will be joining us. And then we'll close the month with a professional monitoring equipment. And I think in that session, Diego will join us, and then we'll break down and demystify some aspects of the professional color monitoring equipment. And yeah, in today's sessions, like I already mentioned previously, we'll just talk about the basic of the color management concept. And I really hope that these sessions will inspire you to dig more about color management and not to get scared and intimidated by color management, because it's the thing that can help your productivity as well. And then if you missed last webinar, or if you want to check out what are the webinar that we already performed this year, we hosted this year, you can go to Maxon Training channel, YouTube channel, and just type in Maxon Training Team, and you can watch all the webinar that we hosted this year and the year before. And if you want to follow Nosman, and simply go to his website, nosman.org, and he has all the social media channel there as well. And last but not least, it is not complete without the t-shirt, right? Same like the previous webinar. In this webinar, you can also get a free t-shirt, but just a caution, word of cautions is that you can only use this code once, and it is only valid for the Ask the Trainer t-shirt sections in the shop. So once you go in the shop, just type in the password, and the password will let you enter the shops, and then after that it will deduce the price. Once you're in the shop, I'm not recommending you to go back out from the shop, because sometimes that could trigger error in the backside and the back end, and it will not allow you to use the password. And today's password, and for November password, I mean, it's color ACES without space, right? And yeah, that's it. And with that said, I really hope that you enjoy the sessions, and I will pass the sessions, the baton to Nosman. So.
Well, hello everyone. If I'm looking there, that's because that's where my visual feedback is. Yeah, I'm gonna share my screen in a bit, but before that, I'd like to just say a couple of words. I see that currently we have around 60 people. I guess one of the reasons this is happening, and let me just show my screen. One of the reasons is that a lot of people don't understand the value of color management and what kind of problems it solves. A lot of people believe that it's something that only has to do with pipelines or collaborations, when in fact that's not entirely true. You could improve the quality of your work in an instant by clicking 3 buttons using color management, and specifically the new ACES implementation that has been introduced a few versions ago in Redshift. So spread the word. Hopefully, I'm going to show you today the 50,000-foot overview of what color management is, what problems it tries to solve, and what you can do if you're an independent artist that doesn't rely on any other sources, how you can apply the minimum amount of this extremely complex and very powerful technology to improve the visual quality of your work. So hopefully I'm going to convince you, and over the next few weeks and the next webinars, you are going to have experts explaining all the details. And I would advise anyone that knows other people in the industry to point them this way, because I do believe that even knowing about color management will prepare you for any different types of more complex projects in the future, and you're not scrambling in the last minute. The concepts are not very difficult. The math, which is a difficult path, other people are doing it. I'm so happy for that. So yeah, let's begin with the very generalized overview. I'm going to be looking at some of my notes over here because I'm relatively old and my memory doesn't work very well. And while we're looking at this simplified visual of the process, let's just talk about color management in general and why it's important and where it's used. So the most obvious use of color management is the following. Every single monitor, in front of me right now, I have 1, 2, 3 monitors on my Mac, 2 monitors on my PC, a laptop PC which is now shut, a monitor on my camera, which is basically the little LCD display on my camera.
And behind you as well.
I have 3 monitors behind me, and showing, none of them are the same. Well, we have some same brands, but I don't have 2 same models. I have an iPad, I have an iPhone, and they all have very high-end screen technology, right? Panel technology. If I make an image, any image, and I put it on all these monitors, every single monitor is going to show me something slightly different. And it varies from my very old monitor here, which shows totally different colors and destroys the color palette, to my more modern screens like the iPad Pro, which I bought with my Aeroplan points, so I didn't have to pay money for it. As many freebies as I can get. And basically, the question becomes, which one of these images, number one, looks better, and number 2, represents reality the moment it was taken? And there's no real answer to that unless you stand in that place when the photo is taken and you can memorize an objective image of that particular photo, so you can compare it based on your monitors. You won't be able to do that. And even that, if I turn off a light here, I'm going to turn off a light, and now you see something slightly different. If I turn on the light without touching anything else, now you see something, again, more lit up, more different. I can turn up the light. So even under the same circumstances, with the same camera, with the same subjects, with the same monitors in the background, just turning on and off or dimming a light, the image presented is very much different. Now, you would ask me, yeah, but if you work in a controlled environment, that's not the case. Well, let's now expand the problem and look at our visual, which hopefully is presented just to make sure we can see my screen, Max.
Yes, I can see your screen.
Oh, excellent. I can't see you, so I didn't know if you were nodding. So here we have the following example, which is synthetic. Imagine I have 3 cameras shooting exactly the same thing from exactly the same point with exactly the same light. And for whatever reasons, it's not the same camera, it's a different camera. I'm going to get 3 different looking images. So in that particular case, the problem is that the technology of each camera, we know that certain brands create better images for specific types of images. Some brands create better skin colors. Some brands create better nature colors, the greens, the blues, and all that. So if I'm a director, if I'm a content creator, and I'm creating a story, and I want to make sure that the colors represent the emotion I want to depict, I need to make sure that the colors I'm actually imagining need to be part of the color spectrum that all my images are going to be a subset of. So because technologically there's not much we can do, we can't force the big manufacturers to create cameras that shoot exactly the same. They use different technologies, proprietary, different lenses, and all that. So this was one of the first, let's say the beginning of the problem in a production setting, is how do we make sure that all the cameras we're going to use to shoot, do our B-rolls and all that, or any other material, will have some sort of color consistency within the post-production process, right? So that's one of the things that a color management system is going to sort of mitigate for you, fix, or make it less problematic. Then, as you can see over here, we have the synthetic image, so the 3D aspect of it. When we create synthetic images, we need to make sure that those images are quite close, from a color perspective, to what we are trying to do, the story color. I'm going to call it the story color for now. Then we have the compositing, which does effects, blurs, streaks, you add lights, you add all sorts of different effects, particle effects, and whatnot. And we need to make sure that the color is consistent over there. And then we need to account for the final color. You need a different color, let's say manipulation, a different color editing for something that is going to be played on an IMAX theater, a different one if you transfer it to actual film, and a different one if you're playing on TV, and a different one if you're playing on the web, on some sort of streaming medium, and so forth. And if you want to take and make a poster, then you have to account for CMYK printing or inkjets and so forth. So the color permutations, even for the output, are quite a few, depending on where you want to show your an image or a video. And color management tries in the best possible way to mitigate these problems. And now I'm going to give you the overview of ACES and how ACES is trying to fix this problem by applying a color management standard. So the number one thing, and ACES is a product from the Academy, the Oscars, and I think the ACES acronym means Academy something, something, something. And you can go and just Google it.
Color encoding system.
There you go. Academy Color Encoding System. There you go. The professionals speak. You can go to the ACES Central website and look at all the techie details. So let's get an overview of this. Imagine we have 3 cameras, which are not the same, but we want them to shoot something that will be translated in an equivalent manner. Sorry. What we do, we put the burden of creating some color transform tables, which are called input device transforms. And what these are going to do is, for each camera vendor is going to have some sort of mathematical table of the colors. And they use all sorts of charts and math and stuff like that. So the colors are interpreted in a way where when we apply these color transforms, and that is math, so we're not going to deal with it, but with some sort of way, it's some sort of driver, some sort of table, translation table. It's going to make each and every one of these images have exactly the same color data. So you can see that these are a bit washed out because I'm doing something equivalent here visually to shooting with log color, where everything seems washed out, but you have much more colors to work with in your color grading and your compositing. So now what we have here, although the data began by being totally different for each and every one of our photos or our scenes, And they all have the same data. So if I go into this little pixel over here, this value of blue, I'm not saying that it's going to be the value you want to see, but all these blue values are actually going to be the same blue value. So we get consistency in terms of the data of the color, and that's the first step. Now, one thing important is these input device transforms, they actually take into account not only the camera model and make, but the type of lighting that's used. And that's a very interesting parameter, because depending on how warm or cold the light is you've used to shoot at the same location, as controlled as it may be, a different warmth, color of light will give you a different result. So one camera can have a number of these input transforms. And all these, depending on the conditions you shot, will provide a let's say a video whose data is exactly the same. So ACES, what they've done here, they've created a color space, and color space is that rainbow. I didn't create an image for that. It's the very typical gamut image you see that has all the colors spread out on a two-dimensional image that looks somewhat like a harp, you know, big round part here and a straight down here. And ACES color space, what is called the, I think, AP0, it can hold such a huge amount of color variations. It's extremely high dynamic range, to the point that a lot of its colors cannot be presented in the current historical moment right now on any output device. So, but for the purposes of archiving, what they do, they say, you know something, we don't want this color system to be obsolete in 3 or 4 or 5 years. So we are going to encode these numbers in ridiculous wide range, so that if in 5 years there's a new kind of monitor that can present us with so many more different colors, we'll be able to extract that data, and providing the proper grading, we'll be able to see much more vivid, bright, and accurate images. So the ACES full spectrum of color is much larger than what we can see now. And I think, don't quote me on this, that it's very close, it's a subset, but it's very close to what the eye can perceive. And the engineers and colorists can tell us if that is true or not. So moving on to the 3D aspect of it. So as we may or may not know, most rendering in all modern render engines traditionally is done in linear space. For whatever reason, you can Google the way linear color space and the gamma and what it does, and why the human eye has a tendency to see more of the light parts and whatnot. So there's a whole theory behind that, which it's not theory, it's actually true. But what we do in 3D, it allows us to not render in linear space, but a specific color range, which is called ACES CG. Now, you would ask me, why did they have to create a special space for synthetic images, for 3D and rendering, and not use ACES, APO, and all that? That is because the way renderers work, they're trying to imitate, and again, this is a very layperson's overview. The way renderers work is very different from how cameras work and how our eyes work. And they're very specific types of lighting effects. I'm going to show you one of them today as an example towards the end of the presentation. So they wanted to optimize the way the renders are done so that we can get the most filmic approach from something that is not realistic. So this particular ACES CG space, although it's narrower than the massive ACES AP0 space, but then again, it deals mostly with the color gamut that comes out of renderers overall. So for whatever reason, this is what they use, and it seems to work. Now, here is the question. I am working in this space. Do I see these sort of washed out images? And the answer is no. There's a good presentation on Adobe Max that was presented, I think, last week from one of the executives of BenQ, the monitors.
Chris By. I think
yes,
it was Chris By. Yeah.
I think so. It's we may be able to put a link somewhere.
Yes, I'll search for it.
It's an amazing resource because it explains, among other things, that even if you get the highest end monitors that any company makes coming out of the production pipeline, and you get two of the monitors that came out next to each other, by default, you will not see exactly the same color on each and every one of them. There's always a manufacturing. It's not a defect, it's the way panels are made that will make it different. So in order for manufacturers to guarantee, number one, that the color you see on your monitor is as accurate as possible, right after they go to the production, out of the production line, they calibrate them. And for each and every one of the monitors, they create a slightly different file, or let's say a data transfer table. What are those called? A color profile that will actually allow what you see on that monitor to be much more accurate and, above all, consistent. So while you're working in this ACES CG space, your monitor, you provide it with an ODT, an output device transform, which is part of the ACES system. And that sort of works in conjunction with that color driver that the manufacturer makes, because the ODT is made by the manufacturer as well. And what it allows you to do is that although internally the renderer is rendering these washed out images, they are presented to your monitor by applying this ODT to make them look, let's say, like the original creator's vision, the color that we wanted to get. So it's the reverse of doing this part, the input part, and this is the output part. And you will see that this, watching things on calibrated monitors with the appropriate ODTs, and I added a lot here, I'm going to explain why later, needs to apply to every single monitor you are using. And the calibration, here's the funny part, needs to happen not only per monitor, but per environmental conditions. If you turn lights on, you need to calibrate your monitor so that the calibrator takes into account the ambient light. If you turn your lights off in your studio, then you have to calibrate again. That's why the manufacturers, the guideline is that every few weeks or every few months, you need to do some sort of calibration to make sure that the monitor has a stable color output. And you can see that both in all stages of your production, whether you're doing 3D and you're looking Cinema 4D and your viewport render, whether you're looking at, you're doing compositing in one of your compositing programs, you have to view it in a calibrated monitor. I'll tell you when that doesn't really make sense, but this is the ideal scenario. And when we're doing the final grading, again, we have to watch it and view it and do the color corrections in a calibrated monitor. As the data goes from stage to stage, from camera to compositing, from 3D or synthetic or any other effects to compositing, and from here to final grade, the data actually is this washed out data. That is what all the calculations are done upon. But on our monitors, we don't see that washed out image. What we do see on our monitors is that converted image to what we want to see at the end. And usually, the final grading that's going to happen here is going to drive us to use a specific lookup table, a sort of a color filter that will take what the original color is and makes it look like the final one. So everyone in the pipeline, although the data is stable and is based on this really wide gamut, everything people see on their monitors is actually representing the creator's final visual view of what you're making. And that sort of wraps up the overall process of a production pipeline that uses cameras, synthetic images, compositing, and final grade. So first of all, are there any questions up to this point? Because I do have a couple of things to say, and then I'm going to show you a real-life example why you should use ACES, although your workflow doesn't look like this. It may not look like this at all. So do we have any questions at this point, Max?
Seems like you nailed it. There's no questions at all. You're doing a great job, man.
Don't wanna wait. Always, Max, don't get carried away. When no one's asking questions, it's either that the seminar is perfect, which is usually my case, or everyone is asleep. Every single person now.
No, I don't think that's the case.
So I'm going to have a sip of coffee. And
Oh, wait a second.
Yes, you do have a
there is one question from Chris, and Chris is asking what software controls the ODT to ACES.
Okay, so that's a very good question because we're not going to use specific software, or let me put it another way. Once a software has been adapted to use color management, so Redshift had some color management, but in Cinema 4D, for example, we do have sRGB or linear, so it does some color management, but it cannot handle ACES. So the software, the companies that make the software, Adobe, Blackmagic Design, Maxon, or any company, all the Red Giant tools and so forth, the companies need to make sure that the tools support this particular color management. The way it's happening currently is that there's an open source project called Open Color Input Output, Open Color OCIO, Open Color IO, OCIO, and that has now since I think a couple of years ago, if I'm not mistaken, supports ACES. And as far as I understand it, every company now that wants to support ACES, it does it through OCIO. And again, if I'm making a mistake, someone will correct me. So as far as, let's say, Cinema 4D itself doesn't support ACES, but Redshift, which runs inside Cinema 4D, does. So from Cinema 4D as an ecosystem, the picture viewer or the render view supports ACES. Now, the picture viewer still lags behind. It applies the transformations somewhat like a post effect, but the render view, Redshift render view, supports directly the Open Color IO, which now comes built in, and ACES. So essentially, it's the responsibility of the software vendors, software companies, to provide you with the software ability for these transforms to happen. It's a responsibility of the camera manufacturers to provide you with the IDTs, and it's a responsibility of the monitor manufacturers to provide you with the ODTs. And if we go to Redshift, and I think I've got it here, and if you go to the render settings and go to Redshift and go to globals, this is now the default place where you would do that. And rendering color space is where the rendering is happening. And currently scene linear is the old school linear we are used to. I'm using that as my base for the example. The display is basically, what display are you watching it on? I only have sRGB displays, so nothing else is going to appear under here. But I'm pretty sure that if your monitors has a specific, is a wide gamut and has something different, it will appear under here. And then the view is, how are we going to transform that data? And currently we have log, raw, and tone map, and ACES SDR video in order for the transform to happen for us to get the proper color transform. I'm going to show you how to set these up, which actually, it's for any new scene, it's the default settings. I'm going to say a couple of things on that as well. But that's where each vendor's responsibility lies, and software is the software, the software developer company that has the responsibility of creating these, or implementing, sorry, not creating, but implementing a color management system, which happens to be now the most popular one, if not the only one, is OpenColor.io, and ACES is where most productions are going to. So hopefully that answered your question. What else?
Yeah.
Yes.
I just want to add up some little things that, you know, the IDT and the ODT, it's a direct communications between the camera manufacturer or display manufacturer with the academy themselves. So whenever there's an update to ACES, I guess you will see some more, how do you call it, IDT and ODTs in the software that you are working on, the whole software that you are working with. And yeah, there are two other questions, Nosman. Let me check. Jason was asking, can you compare the difference between conforming to ACES and REC 709? Is it like, I'm not quite sure, Jason. Are you asking about project setup, or what do you mean? If you could, you can just like elaborate your questions in the questions panel. We'll take it from there.
Yeah,
And there's the
expert
second question,
questions.
or do you want to answer that?
No, these are expert questions that have to do with the application on specific tasks, and those things are, I guess, are going to be presented mostly in the next series of webinars.
Okay,
Because
seems like
yep,
Jason just answered. It's he's working in Premiere primarily. So I think you have to show up again in one of our sessions, in the grading sessions. That would be in the fourth, I guess. Yes, the fourth sessions. We'll be there, and we'll talk about how you set up the ACES color management in the grading environment. But on top of that, Sharon is also asking if I think this one is good for you, Nosman. I think you can answer this. Um, do we really need ACES if we're not working with camera footage?
thank you, Sharon. Sharon always asks the best questions. That's why she's a friend. Greetings to Texas. So here's the next part of my presentation, which hopefully is going to provide you an answer for exactly that. So just to base the question and just frame it, the question is, well, I'm not using cameras. I just do 3D, and the occasional, you know, JPEG I use from some sort of stock footage library, and I just want stuff to look nice. Now, here's the question. Number one, if you enjoy what you're seeing on your monitor and no one else is going to see it, then that sort of solves all your problems, right? If no one else sees them other than you, your family, and your friends when they come home on your monitor, and your monitor is showing exactly what you want to show, then there is no problem. You do not need color management. To the point, you can have a black and white monitor and make black and white stuff, and just you know, you can render color and they will show us black and white. You can say, hey, it's a nice, you know, old style photo. But if anyone else is going to see it on a different monitor, then you need to make sure when you're making something that it looks as correct as possible, number one. And I'll tell you why that's not always the case, unfortunately. And number two, the way the ACES-CG calculations happen with any ACES activated or capable renderer allows for certain things to look much better without you doing anything else. And this is the example I'm going to show with this scene here. Now, mind you, there are exceptions to this, because we can control our own pipeline and our own environment. What we cannot control under any circumstances is the device on which other people are viewing our content. You can make something beautiful and you go to the person back in the 80s that didn't have a color TV, right? And that's me. We didn't have a color TV in the 80s. We watched TV on a black and white television, right? We bought our first color television in, actually I bought it 21-inch, and it was 1988. That's the first time we got a color TV. So up until 1988, it doesn't matter how good your color grading was for any show that we're watching on TV. We could only watch it in black and white. So
Mine
that's,
was mid 90s, man.
hey, there you go. So that shows that no matter how much color management and technology you throw at things, you cannot go into someone's home, grab their black and white TV, throw it out, and give them a color TV as a present. You could, of course, do that. But that shows that because we can't control the output, if someone has plugged in their television or not, we cannot control that. So that's the example. But if for the average person that's going to see it, the majority of people that have sort of the run-of-the-mill monitors or run-of-the-mill televisions, the better your image looks on your calibrated setup, the better it's going to look on theirs. It's not going to look as good as yours or exactly as you want it, but you've heard of the acronym GIGO, garbage in, garbage out. So it has the opposite. The higher the quality of your content is going to be, the higher comparatively it's going to be on a lower quality visual product like a monitor or a television and all that. So that is one thing that you can solve, the quality of your work seen by others. But here is what I'm going to show now is the following. First of all, when you open a new scene, in Cinema 4D with one of the latest Redshift installations, 3.5 something, and you go to Redshift, in the Redshift settings, advanced globals, you will see that the default setting is rendering color space ACES CG, display sRGB, because that's all I have, and view ACES 1.0 SDR, standard definition video. And that's because I don't have a high dynamic range monitor or something like that. So the ACES color space and the color management is by default activated. But if you open an old scene that was created inside Cinema 4D and Redshift before they introduced the native OCIO support, then it will open with these settings. The color space is scene linear rec 709 sRGB. That is the closest we have to our linear, pretty much identical. And sRGB, there's an untone map, because what you render, the data is what you see. Whereas in ACES CG, you don't see the data. You see the translation of that very wide gamut data into your native, the ability of your monitor to show that those colors. So I'm going to take this particular scene and I'm going to show you something that looks absolutely disgusting if you don't apply ACES color management. And by the way, this was my first and only NFT I did. It was bought by a lovely lady in Southeast Asia, and she was very proud of it. I sold it 0.2 Ethereum. I didn't do it for the money. I'm just proud that someone halfway across the world has something that I made, and they are treating it as a piece of art. And that was the first time in my life, when I was 56 years old, 55 and a half, that I could call myself an artist. Because other than that, I've done nothing of artistic value. Now, let's move on to the essence. I've got these green panels here and these red LEDs. And I'm going to sort of zoom in here, and I've activated on my camera here, I've activated my, not bokeh, my bloom, right? I have this set to this bloom, but I can barely see it. I want these LEDs to be really, really bright. And these are using an incandescent material. So I'm going to double click here. I'm going to select this and set the intensity to 15. And activate the render. If you don't activate the render, nothing is going to happen. So it's hopefully, and look at that muddy result. This is not good. I don't like this. But this is all the renderer can give me currently, doing the render in this color space. I'll have the same problem if I go to the panels and set the panels to 15. this is going to be disgusting. Now, the problem is that because we are used to this, because it's the default behavior of the renderer, we're going to tweak the lights. So essentially, I cannot get this to look the way I want it to, because these highlights are too blown out. There's no roll-off here. The problem is the roll-off. We have this hard cut here and here, and it doesn't look good. And watch the magic here. If you go and you say, I'm not going to render in scene linear, I'm going to render in ACES CG, immediately we see a difference here. And I'm going to set this to SDR video. Look at how smoother, how much more of the gradient we get. I mean, now the screen is white. This is what happens when you put too much energy, even in different light colors. It starts blowing out. It starts becoming white, and then the halos become more colorized. And this was just by switching to ACES, nothing else. So one of the huge advantages of ACES is because the way the math happens internally, the data that's being crunched to create the images, they've emphasized on what's called highlight roll-offs and intense light sources and so forth. And it allows for more information to be shown where the highlights are. Stu Maskovich, he wrote this amazing article. If you have a link, Max, please provide it, talking about you know, the upsides and the downsides of ACES and all that, and talks about the roll-offs and the highlights and all that. And that was one of the things that convinced me that I should give it a shot. And this was my first test. That was the funny thing. I was just playing around with this, and I realized just by switching to a different color management system, I got something that looks, compared to the previous one, spectacular. I mean, shall we take an image? I'm going to take an image of this. I'm going to set it back to the other one and go back. So working space, this one is standard and untone mapped, and take another one here, and yeah, turn it off. And here's the ACES. Oh, and it's applying, I think it's applying an extra color now. Yeah, so there's something I need to, I think that affects, there you go. So this affects your picture viewer. But nonetheless, look at the difference. How much more highlights we have here, and how much more we sort of lost the gradients over there. So let me just set this back to ACES CG. You can do your own experiments, and if you have a calibrated screen, you'll see it a bit better. I don't even know why it's so saturated now, so I probably touched something I shouldn't have. Anyway, yeah, I think I touched some settings I shouldn't have touched. That's why now it's oh yeah, because it's rendering. Oh my, it's not rendering. Here's the actual render. It was processing one of the selected images. There you go. So now I've got my very strong highlights. I look at these things, I feel blinded. They're so intense, and yet again, I'm not losing any data. Now, one thing you need to remember is because of this tendency for ACES to like to deal more, put more detail in the highlights, you do overall get slightly darker images. But the only thing you have to do, just increase the intensity of your basic lights. I think that in this particular case, if I go to my dome light, which is my main lighting source, and increase this a bit, I'm going to gain back part of the overall lightness I lost. But I would challenge anyone to go to any scene that has glowy effects or detailed highlights and reflections, where you get high dynamic range skies reflecting into surfaces and so forth, and in an old scene, and save a backup, save a separate scene, and convert that to work with what are the defaults. ACES CG, whatever your monitor is, sRGB, and ACES SDR video, again, based on what your monitor is. And I guarantee you, in the majority of cases, you are going to get much higher visual fidelity and quality in all those places where it seemed hard or impossible until now. And as far as I can tell, we are lucky because they're throwing a lot of money in the whole ACES color management from vendors, from software companies, and all that. So it won't fail like any other color management system we've seen in the past. It was always diluted, or people create their own proprietary ones. This is the first time the Academy has, I would guess, managed to put their foot down. And the technology they've created, actually, it's quite spectacular in terms of the math involved. And I would suggest go watch some of the videos they have. They have nice little discussions on ACES Central with a lot of the scientists and other people that participated in the project, and you realize what a monumental effort they put in to create this. And what I find interesting is it's not one of those standards where only high-end studios can take advantage of. You can currently, with your current installation, you can take advantage of it to the point where your visuals are going to look better. And there is a number of videos that started circulating over a year ago, ACES in Cinema 4D, that show you more and more of these examples of how much better your color is if you use ACES. And yeah, Maxon in all their products, I think they're going to follow suit slowly and start pushing it to work with absolutely everything. But I'm very optimistic about this, and I do believe it's such a little. There's no overhead anymore. You don't even need to switch anything on. It's on by default. So the only thing you need to make sure is that if you open an old scene and you copy and paste it into a new scene, it will look different because your color management settings are different. So don't forget, switch to Redshift, go to Advanced, go to Globals, and if you want it to look like it looked previously, just switch this to Working Space 709 sRGB for this, and untone mapped on this. As far as the specific ways you're going to use this with compositing software, this will be a subject for one of the next webinars we're going to have, where the real experts are going to actually show you how to use it in After Effects and a bunch of other software. So
yeah, I think next week Lionel will be explaining more detail in Cinema 4D and Redshift. And then after that, the week after, we'll see things in After Effects and compositions in ACES framework.
Mm-hmm.
Sorry to interrupt you, Nosman.
Oh, no. I'm basically done. I want to give you a couple of statistics. The ACES ultra high dynamic range has 30 stops of dynamic range, and that is it's a ratio of 1 billion to 1. So that is quite huge. Sometimes, so and a bit of terminology, I think the difference between subjective and objective color. Objective, I'm going to leave it for the experts. I don't want to say something that is opposite for this. The last little note is that if you're still finding it hard to sort of understand the difference between gamuts and so forth, the most simplified example, similar to my color TV, is if you shoot something with a color camera, a photographic camera that has color, and you want to convert it to grayscale, black and white, that's a very easy switch. You remove all the color data and you leave the luminance data. But if you shoot with a black and white camera and you want to convert it to color, then there is no real way to do that other than go and colorize each surface yourself. This is the equivalent, the color being the ACES color space that has all the information, and black and white being the space we are working in, which is a subset. As long as we retain the color information, we can make it into a sepia, we can make it into a black and white image, we can make it in a duotone, tritone, anything we want. But the opposite does not work. So that's why ACES works in that extremely high dynamic range space. So all your the data that can be captured is retained to a very good extent. So in the future, you can use even better monitors and even better software to extract every little amount of detail and color from those images. And thus ends my presentation.
Wow, bravo, kudos to you, man. You are doing such a great job in explaining those technical terms in such a understandable manner. So kudos, that's really great.
Thank you, thank you. And
if you don't mind, I can show some like extra resources to our audience to direct them to a, to research, to direct them to do their further research.
Yes, please.
And let me share my screen. Dan said, thanks guys, this was refreshing lunch break. Thank you so much. So, all right, I'll show my screen. So I think some of you, for those of you who are still intimidated by the technical terms, IDT, ODT, color spaces, what is that? And it's still like kind of like confuse you. I think I already paste the, how do you call it, the link into the chat. And I do really invite you to visit cinematiccolor.org and download the PDF provided there. And I think this was a SIGGRAPH paper, and it was like doing a great job in such a great job in explaining all those technical terms. And I think it was written by one of the founder of the Open Color IO as well, Nosman. And regarding I think you mentioned that, by dropping in ACES, we got like the significant improvement in the look of the scene as well. And I think about that, you may want to the audience, I think you may want to research more on what is called the ACES RRT, or the reference rendering transform. Because on top of the ODT, there's also things going on, which is called the reference rendering transform. And the reference rendering transform was historically, it was done by the Academy in cooperations with Fujifilm. And the framework back then, it was targeted for the filmmaker who was still working in the film. So I think that explained the slightly more filmic look that you got from the ACES framework. And to read more about that, there's a paper from Fujifilm as well. And I kind of like how do you call it, paste the link into the chat as well. So those two resources, I hope I do invite you to read more about it, because it's such a great resources. And understanding the framework, it could help you with your pipeline.
Max, can I intervene? I'd like to touch upon some of the questions, since we still have a few minutes to go. When you're done with what you're showing, just let me know, and I'd like to address.
I'm done. I'm done.
Okay, so my fellow Greeks. So every time I render in Redshift and I see the picture viewer, so basically, what I think you're seeing is because the picture viewer is not yet color managed, the transformation to the ACES SDR is applied after the fact. So what you're seeing, that pale image, is actually the data that the compositing or the grader is going to get. It's that pale image I showed in my original layout. So you're seeing the render happening on the data level. So you're seeing the letters coming down from the matrix, and then it applies the transform, so you can see what the director was intending for you to do. When you're exporting this, and I'm not sure, Lionel is going to show us the proper way to export this to your compositor. I think that the image that's getting exported to the composition is the pale image you're seeing, without the LUT or the ODT being, I think it's the LUT that's being applied to it. But because After Effects, in theory, will provide you with that transform, although your image is the pale one, on your monitor, you're going to see what you see as the final one in the viewport. You shouldn't save that darker image you see after the transform for your composition, unless you're going to do compositing not inside ACES space, right? So if you don't use any color management, then that's the image you're going to do. But if you can continue your color management in After Effects, then you want the pale image. So that's as far as I understand it. Let me go down a bit. So that should, yeah, and that should answer Sharon's question. And again, Lionel is an expert at this, and he will show you everything. Materials, David Kerman. Yes, the implementation of ACES and OCIO in Redshift can predict to a good degree which color space your textures are. Because this is supposed to be written in the metadata of the file. If for any reason it's not in the metadata, then you will have to go and provide the proper color space. If you don't know it, then there's nothing really I can do about that. No, when you get an image, if you create it yourself and you apply a color space, color management profile to it, you need to know it or make sure that you do. If you receive an image from someone and you want to work in an ACES color managed sort of workflow, you need to make sure as much as possible that you know that data, that they give you that data. I know it's one of the hardest things to do for a client or someone else to provide you with all the information you need, but I think at the end of the day, the auto is going to give you, I think, 99% of the time, the correct color transformation. So, color management is so important. Yes, you're very welcome, Dims. Let's see what else we have. In terms of bringing images into Cinema 4D, is necessary to convert the images. So that ties into my previous answer. Only if the actual color profile is not visible in the metadata, and auto will work most of the time. If you start seeing weird things, just play around. I mean, eyeballing is my superpower, and I hope you use it as well. Turn your to raw and color images, ACES, and then come HDRIs. I don't know what YouTubers, yeah. I've seen the YouTubers that say that ACES is cool. So, yeah, the time didn't change in the US. And you, Isaac, if you were following me on Twitter, you would have known. So follow me on Twitter so I can tell you when the time changes. In the United States and Canada, the time changes on the 7th of November. So you get your extra tidbit of information. Resource, blah, blah, blah. And yeah, I think now, with a minute and a half to go, I think I am done now. Thank you very much.
Well, thank you very much, Nosman. And let me do the housekeeping. Let me share my screen. So yeah, we'll upload this the recording of this webinar into our YouTube channel. It's called Maxon Training. You can just simply search in YouTube Maxon Training. And shortly after the webinar is done, and then we'll wait until the recording is uploaded to the database, and then we'll upload it to YouTube. And I also would like to point you out to the certifications page. If you like to do some memory jogger, you can do the elementary knowledge test, and those tests ranging from Cinema 4D, Redshift to Magic Bullet Suite, for example. And if you want to do the Cinema 4D comprehensive certifications, you can also check the website maxon.net/certifications. So with that said, follow Nosman in his Twitter, nosman.org, and follow the link there. And it's been a pleasure to have you, Nosman. Thank you so much for the knowledge shower to us. It's been great, and I really appreciate it. I hope everybody is agree with me that it was such a great session. Thank you so much.
It was my pleasure, and yeah, thank you everyone for coming. And if you have any general questions, yeah, what's the platform to ask any questions so that
training at maxon.net.
Training at maxon.net, and
Yes.
yeah, our other instructors, which are experts in the field of color, will be able to provide you with specific workflows and answers. So thank you very much for coming.
Take care, everyone, and see you next week. Bye-bye.